with aeration. It's important for aeration. This is the basic history layout of this service. Okay, from the view of the water, we can read water quality condition as the natural habitat, which are not ranging to 5 pm, we expect between 7 to 9, it is above 5 pm. So the same is the habitat. The first outfit is to be fair, starting in Sutra, in 3 months to the next 3 months. Totally, the domestication process is 6 months. And 3 months, the pig is pretty fat. So the next month is high protein pellet, so small pellet, and then with 2% of the biomass weight. The spinning process lasts 8 to 10 hours. The laying egg, female plants in the water within the same spot. So this can find the stone in the behind the stone. So that after spinning is complete, the female what in the nursery for recovery again. This current condition of internal and external challenge. The data which appears in the 2020, 2023 mangrove has been decreased. So that its internal challenge is experimental, but it's the ultimate solid that we need to make the domestication the clinical utilities are represented in people to 12% decrease. So external challenge is that the population is producing species from the public water. The result of fishermen in the Kali. This is the natural habitat formation habitat in the Kali, and it's the view. So the result, because the data items decrease before the introduction of species from fishing community is the so this the introduction invasive species as non-harmful. Harmful is the as predator species. So that the decreasing of the past year. This is the example. The solution of the external challenge, the post information species, can be the regulation of government. So that the check from our result, I want to share it in the government internal room so that the product can be and the ultimate domestication, not the introduction specification. The stabilization in the water is also the conservation effort. It is the point, important point, but is the domestication is not the sustainable concept. So is the ensure the sustainability and benefits. The result conservation efforts are referred including ex situ conservation. Okay, this is the economic value of the ocean, the natural rights, and the price and so forth. The ocean mountain has been indication product or geographical indication atau surat indikasi geografis is the so special in the mountain. So that the 1 kilogram ocean to 2,300 rupiah. This is the conclusion. The domestication are successfully from the industry and as well 20%. So we can international or tantangan. The current domestication process still going and to support domestication conservation activities through regulation. The external challenge, domestication was conducted with an executive effort, so the increased introduction and interesting species can be the Next is all the objective. The solution, the cooperation of various stakeholders is necessary to support the investigation, conservation activities through the regulation. Thank you. This is our research. This is actually in the teman channel apa. The topic is investigation. We have discussion or service or question. I will have to participate. Thank you. Thank you, thank you for Mas Ida for the presentation. The next presenter is Ibu Sri Ayu bagian dari Gedung. Thank you for the time. Good morning, everyone. This is my presentation. Let me introduce myself. My name is Udayana, and you can call me Untuk. I'd like to give a presentation about mangrove distribution based on characteristics to subscribe. In my presentation, contains of four chapters. Chapter 1 is introduction, and chapter 2 is research methodology. The third is result and discussion, and the last is conclusion. Okay, next introduction. We know mangrove is one of the plant communities that can grow and adapt by to areas affected by size and salinity. It has many functions in ecological, socially, and economic roles. The excessive use of mangrove without being balanced with rehabilitation will only cause damage to the mangrove ecosystem in order to support the success of management for mangrove forest. It is necessary to pay attention to the factor that influence mangrove growth. The substrate condition is one of the factors of mangrove growth. It can affect the composition to the type of vegetation. One of mangrove area in Bali is in Benua Bay. Benua Bay area is a strategic area that close to the center of tourism and business that get a lot of pressure to mangrove area. The pressure that occurs may lead a decrease in functions and area of mangrove. Therefore, it's necessary to study the distribution of mangrove based on characteristics of sediment substrate in the Benua Bay. So next, this research was conducted in mangrove area of Benua Bay. This study used purposive testing, which was carried out on 25 plots using 10 equal centimeter convex. Next, in each plot, data were collected by recording and identification of mangrove species based on identification by North and Andaman and data collections of mangrove community structure was carried out using vegetation analysis approach by measuring the stem circles of its stand on the research plot using a pulse method. And then the substrate sampling was conducted 3 times using a soil auger at a depth 50 centimeters. And then the substrate samples were then composite for further analyzed at the laboratory. And then data analysis for mangrove community structure has obtained in each plot were analyzed for density, dominance, frequency, and relative value to determine important value index, and to get the percentage of its fractions prime fractions to track using the formula according to Sugiharyanto and Kotima. The formula we can see in the slide, and the results of sample analysis can be determined based on the texture ratio. And grouping of mangrove species based on substrate characteristics was carried out by identifying mangrove species that grow in its substrate at all research plots. Based on the result of this study in Benua Bay, were found 8 mangrove species, namely Rhizophora scolata, Rhizophora sonata, Rhizophora filosa, Sunelati albon, Udayana ginoriza, Ectocaria hagalgota, and Seriopsagal. The result of this identification species show similar previous research conducted by Wianto and Faiko in Benua Bay. In this study, the highest important value index was found in the Rhizophora apiculata, while the lowest important value index was found in Seriopsagal. The important value index of the species can indicate significant of the type role in location. That we can see, Rhizophora apiculata is dominate in Benua Bay area.
Oh.
In Benua Bay area, dominant substrate fraction contains sand fraction. The high content of sand substrate material carried by seawater during high and tends to be slow when it reaches causes the substrate to settle around the mangrove ecosystem, which causes a large fraction of sand. And the whole of Benua Bay area has 6 types substrate. The substrate we can see in the slide. Its namely sand, loamy sand, loam, sand loam, silt loam, and silty clay loam. If we view from the side of substrate, sand loam is dominate in Benua Bay area. Based on my looking on the side of substrate, Rhizophora apiculata were found in all types of substrate. This is presumably because Rhizophora apiculata has good adaptable to various types of substrate. Okay, conclusion. In the mangrove area of Benua Bay, were found 8 mangrove species and dominated by Rhizophora apiculata. And then were found 6 to 5 in grouping of mangrove species. These one characteristics mangrove we found Rhizopora apiculata was found on all sides of substrat. Okay, that's all about my presentation. Thank you for your attention. Okay, my presentation is this. It's nice presentation, I think, especially for me, because I invest in my group. Okay. The third presenter is Agung and Good morning, everyone. Before I begin my presentation, let me introduce myself. My name is Udayana from Fisheries and Research Center of Udayana University. In this special occasion, I will present my research about estimation of organic carbon storage in non-ecosystem benua ribbon. So let's start from the research background. Okay. Global warming is an ecosystem imbalance usually increased in the Earth's average temperature due to an increase in the amount of greenhouse gas emissions such as carbon dioxide, carbon monoxide, CFC, and methane. So mangrove forests have many important functions in the environment, such as fisheries, coastal protection, like food, and climate regulation. So when we talk about climate regulation, we know that the mangrove forest has a important role in carbon field. That Indonesian mangrove has capable or two-story total carbon like construction or for forest burning that is made contribute to global warming. So this study aims to determine carbon storage in the mangrove sediment in mangrove area of benua Bali. Let's move to research methodology. As we can see, this is the mangrove the research map that research was conducted in the benua Bali mangrove area that is located in two districts, in Redaksi and then Pasar City. Determination of sampling point is using the composite sampling that method by considering accessibility. So data collection was carried in 25 research plots that with two different depths, such as 0 until 50 centimeter and 50 until 100 centimeter, and the sediment sample were taken on a quadrat that measuring 10 equal 10 meter using a soil auger. As you can see, this is the shape of the quadrant concept. So next, so how we collect the data collection? So before first of all, before sampling, organic waste and leaf must remove from the surface soil surface. Next, pouring was material by using a soil auger divided into the soil vertically at a predetermined location to a specific depth. And then sediment sample were taken into depth like before, namely 0 until 50 centimeter and 50 until 100 centimeter. And the last sediment sample were taken in 3 recipients that activity based on its plot, which were then composite. So, okay. So I decided to that analysis into four. First is math in laboratory. Sample was in Balitang laboratory using a multi-book method. And after the data, we calculate the data using some equations such as soil density, soil carbon density, and the last is soil organic carbon. That's the equation can we see on the screen. So, turning our attention now to the results and discussion that the first one is the book density based on the data analysis. Carry out that the soil book density concentration obtained on average range from 0.76 until 1.0 gram per centimeter cubic. And the book density concentration is quite different with the another research such IUFO 2020 that which obtained book density concentration ranging from 0.55 to 0.81 gram per centimeter cubic. The variability of the average of soil book density in its plot can be seen on this graph. Okay, next. The second one is soil organic carbon density. The variability shown in this graph show that the variability of soil average of soil carbon density. That's the average value of soil organic carbon density at the 0 until 50 centimeters is 1.83 gram carbon per centimeter cubic, and the other one is that of 50 under 100 centimeters is 1.89 gram carbon per centimeter cubic. That's according to the research by Redaksi et al. 2014, tell about the vertical distribution of soil organic carbon density is very important for carbon budgeting, and define a carbon sequestration strategy. So the last one is soil organic carbon that we show that a graph that a breakdown about the below one is the variability of average soil organic carbon in each plot, and the second one is the graph show that the soil organic carbon in two different depths. That the average organic carbon content at a depth of 0 until 50 cm is 91.618 megagram per hectare, and that of 50 until 100 centimeters is 94.296 megagram per hectare. Then the average spatial distribution organic carbon content range from 30.154 megagram per hectare to 204.769 megagram per hectare. That we can see that the biggest value of organic carbon sediment show in the 50 until 100 centimeters. So the conclusion about this research that in this research location, we know that the average organic carbon is between 20 megagram per hectare until 204 megagram per hectare. And based on practically, we know that the organic carbon content is bigger in the depth of 50 until 100 centimeters. So that's all my presentation. Thank you for our attention. See you in the next. Thank you, Ms. presentation.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Let me introduce myself. My name is Septian Nugraha from Udayana University. Today, I would like to presenting the result of our study that has the title Development Strategies of Sustainable Diving Tourism Post-Tsunami in Lantai, Indonesia. This study consists of Ms. Ani Rimawati, Mr. Mutahli Khalifa, and me, Septian Nugraha, as the presenter of this study. Okay, so let me start it. Lantai is home to of natural wonders such as forests and seas. This is why Lantai has a great potential for ecotourism development. Ecotourism in Lantai itself has rapidly grown and has become a promising sector in boosting local economies. In Pandeglang Regency itself, Lantai is one that utilizes the coral reef ecosystem as their source of income. But in 2018, Banten Ocean tsunami was affected to natural disasters and that affected to many sectors in the regions. Infrastructure and marine ecosystem is one of the most affected sectors that was hit hardest. And the coral reef ecosystem was also affected by the tsunami. Many coastal communities losing their source of income as the providers of tourism services. And according to Pandeglang Statistics Department 2022, the numbers of the visitors to Pandeglang are increasing since 2019 until 2021. And that affected not only to the coral reef ecosystem, but also affected to local communities' economy and regional security. Therefore, an effective strategy is needed to develop the coral reef ecosystem as their internal strength in Lantai to in order to attract a tourist interest. A healthy coral reef ecosystem will be increasing the numbers of the visitors and their effective to local communities and regional security. This study aims to analyze the stability of coral reef for diving ecotourism and analyze the sustainable diving ecotourism development strategies that can be implemented. This study was held on July 2022, located in Lantai, Pandeglang Regency, Banten Province, Indonesia. In Lantai itself, there are 4 diving spots. They are Gedung Island, Karang Pemecahan, Karang Gundul, and Tanjung. This study was quantitative, and focus data on this study is including coral reef conditions, suitability of diving ecotourism, and ecotourism management. For coral cover, I'm using underwater photo forensic method by Gianco et al. 2014 to collect photo of coral condition. Then for identification, I'm using CPCE software to determine the amount of coral cover. For the assessment of diving ecotourism, I'm using a guidebook of ecotourism aquatic or aquatic operation by Udayana 2019 with 6 parameters. They are coral cover, water brightness, coral depth, coral life form, reefs, and currents. And for tourism management, I'm using the questionnaire about including attraction, accessibility, amenities, and service and coral reef. And the questionnaire was given to 35 respondents in Lantai with a specific criteria. Then the result of the questionnaire was analyzed by gap analysis method to get now the tourist satisfaction. Is the result of the sensibility. Lantai are unsuitable for diving tourism by a low percentage of coral cover, low diversity of coral life and a reef base. And as you can see on the result, and the result is the weights multiplied by the coral cover and reef base are pretty low and even zero. And as we can see, the diving tourism suitability itself, Udayana Island is categorized as very unsuitable with 0.94, Pemecahan 1.5, Karang 1.80, and Tanjung 1.67. For the suitability value, categorized as suitable is needed for more than two. Then the brain capacity cannot be calculated so by other way are unsuitable for diving to. Next is the result of the questionnaire. And as you can see, all the aspects of the assessment in tourism destination has a gap between tourist expectation and tourist perceptions. And as you can see, amenities has the biggest gap than the other. It is minus 22.4 with no emergency alarm in the area. Then the ancillary service minus 7.6 with no gas station near the area. Then the quality is minus 6.6 with poor condition of moral conditions. Then the attraction minus 7.4 for access is minus 30 with no public transportation to destination. So for the management strategy that I recommend for implemented are rehabilitation for coral reef ecosystem in other way and monitoring and supervising the condition of coral reef ecosystem with routine and collaboration and do improvement of tourism facilities. For the conclusion of this study is for the diving tourism suitability, by the way, are unsuitable for diving tourism by values and low percentage of coral cover, low diversity of coral life form, and low abundance of reef fish. And for the management strategies that I recommend for implemented are rehabilitation for coral reef ecosystem, then monitoring and supervising the condition of coral reef ecosystem with routine and collaboration, then do improvement of tourism activities. Okay, maybe that's all from me. Thank you for all of your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Dian Nugraha, for the presentation. And next, we'd like to invite Mr. Abdurrahman Abdul. Yes. Thank you.
Very much. 15 minutes. 10 minutes. Okay. Okay, I try to pass. Thank you very much for the time. I will present my presentation about comparison of mangrove canopy coverage. Currently, I'm using remote sensing data, which is Lantai 8 and Lantai 9, immediately Lantai 9. And then with several vegetation index in Bali National Park, West Bali National Park. Okay, next. Okay, must be. Okay, this is the outline. Okay, next. Okay, this is distribution of mangrove in the world. You can see in the world is the species of mangrove in the world is the rich one is you can find in Indonesia. You can see the red one is the rich mangrove species in the world, and then the green one is the lowest mangrove species. One of the rich mangrove species in Indonesia we can find in Indonesia in Bali. In Bali we have several place or area of mangrove, which is like Benua Bay, and also is Prancak, and also in west part of Bali. Okay, the mangrove we can detect with remote sensing data. One of the data is can use Lantai. We can see from the figure in the below one. You can see how and how the remote data can detect the like coverage of the mangrove or vegetation using the characteristic. You can see from here Like when the green vegetation or green spectral is high, we can detect the good vegetation or good count of vegetation, but low in the in the spectral in the green one, we can detect the not health vegetation. Okay, next. In Indonesia, we can see the mangrove area is about 3.3 million hectare. It is, we can see the red one at the area. The last one is we can see in the Papua, it's about 1.5 million. But in Bali Tenggara, maybe just about 2% or 3% of the mangrove area in Bali, in Indonesia. Okay, next. Now we can try to apply new satellite data in this line and compare them more order satellite data informasi. This is 2013 and 2021. Lantai 8 and Lantai because the two data have the like two sensor with the same characteristic, but we try to understand the performance, and then we know the characteristic of the satellite to catch the mangrove buffer. Okay, next. Okay, this is the location, the image processing like this, and then next is the result. I'm sorry, this is the next. This is reconstructive index we use to understand the characteristic of the mangrove canopy and the relationship with the spectral characteristic. Okay, next we use a global sampling reconstructive index, and then this the method used, and then next this the result. We can see in this result. This is part 8. The relationship between characteristics of the spectral and also vegetation cover is high. Start from 0.6 until 0.8 in laser 8. Next. But for laser 9 is more lower compared to laser 8. Just 0.3 up to 0.4. That's why maybe this is because of we use the more long data about the 1 year data. The characteristic of the spectral is maybe not so good for the long data, but we need to understand more in more detail in the next study about when we use the data is more short data. Okay, next. This is conclusion. Based on this result, this is faster study to performance cover the number 8 and number 9 in estimating mangrove canopy cover density. That is suggests that number 8 has better performance than number 9. The CVI integration is more it's the highest relation, but we need to further study. Understand the reason why number 8 performance better than number 9. Thank you very much.
Thank you, Mr. Abdullah, for the presentation. Because we still have one presenter in this section, online session. I think we continue to the last offline presenter, and then we go to the one next session, discussion and listen. Right? With Mr.
Kalau bisa pindah-pindah di mana? Oke, bisa. Oke, yang kanan kiri ini jadi nanti saya Okay, hello everyone. My name is Udayana. Today I will present my result of my research in second international seminar on fish and fisheries science. And I hope the professor today can provide benefit to all of us. Okay, today my presentation with the title macroeconomic analysis using different vegetation index or NDVI and empirical photography or HP method in Tahura Merakai Bali. Okay, the outline. The first introduction, relate background and problem, second methodology regarding location, method and analysis, then discussion regarding method of time and their discussion, and the last conclusion related role, answer, and solution. Introduction. Macro ecosystem have many important functions like biological to habitat for aquatic biota, physical function to absorb the carbon, and physical function as always barrier. So over the time, the mangrove ecosystem continues to decrease. One of the parameters for the degradation of mangrove population is the closure of the mangrove. So it's very important to monitor the condition of and if we monitor a large area with manually method, will require a lot amount of time, effort, and a cost. Like that, this picture you can see if you take the field data with a manually method, you will but if you can buy the field data with a manually method and use the remote sensing technology and the process that can be the most effective and efficient solution. So if you okay, there is a couple with 10 extent methods translate for that. The canopy procedure was analysis with two different methods, which are empirical photography and analysis with imagery and NDVI method to analyze vegetation density of sentinel satellite image. Result and description. The equation for calculating the normalized recurrent vegetation index or equation NDVI using sentinel-2 satellite imagery is as below. NDVI equals new mean rate divided near plus rate, where in near is revealed as a bandwidth wavelength between 0.75 to 0.9 and range divided as a wavelength between 0.63 to 0.7. Okay, the result of the density calculation based on NDVI, the area of the mangrove area in Tahura Bali is 186 hectare with the following categories: scarce, medium, and thick. Okay, the hemispherical photography. Percentage of mangrove coverage equals P255 divide sigma P multiply 100% and pixel canopy or P225 equals total number of pixels or mean number of sky pixels. For example, if you have value P255 like that, sigma P like that, so the percentage become canopy coverage the P255 value divide sigma P value multiply 100%. This is the value. But all camera have the same number of pixels depending on the cycle and brand and camera present. The camera has a photo quality especially of megapixel according to condition normal setting 12 million. And it is the accuracy test. We conclusion metric in evaluation produced to make sure the performance of a model. Okay, where in this study from the total number of sample or field data, 70% was used to build a model and 30% was used to conduct accuracy test. This is the value of test accuracy. This is overall accuracy, 81%, and information space density have register accuracy of 0.85 or 85%. Medium density have a product accuracy 72%, and then density have a product accuracy 83%. With a kappa test, overall 0.67 or 67%. Okay, conclusion. The result is in the NDP tadi show the mangrove in the Tahura area at a surface of 1,060 hectare and dominated by the gas class of 886 hectare medium class and a surface of 89 hectare area and 109 hectare for the space class. The accuracy value of this method showed very good with entirety accuracy value by 81% and 68% accuracy was included in the substantial agreement category. Today, it is necessary to carry out future research by combining several other vegetated index so that consistent value is produced. Thank you for the time.
Okay, now we are continuing with the discussion session. If you have any questions, please raise your hand for the offline participants. Please stand up if you have any questions. For the online participant, maybe you have any question, please write your question on the chat number. Or right hand.
You say there is pasti kan bisa tidak angkara we not see in the algorithm. Still the is still big population. Oh, I think it's because boleh apa?
Yeah. That yes. It's not. How is financial yes in the total from the improvisation from the district where the local in the midst in so in the from even here making the around the organ tell me whether the the physical community is not responsible tidak bertanggung jawab itu nah sudah menyebabkan ini menjadi hal yang menolak saya. Hambal is like something very like become so big but it's hambal is yeah yeah saya panggil hambal but it's the fishing community is not extending is fine not to expand start okay so
Maybe yeah, it's hard to start here to but to ignore the Hambala again. But how to manage the Hambala, the one the manage the population of something like that. Like maybe how to make some good food with Hambala and then tourism is can maybe this is one of the possibility how to make the population of Hambala. So the big fish is I think good enough to make people go there to get cut the tourist to cut the big fish I think. This is one possibility to manage the population of the Hambala. This is maybe the suggestion of the university. Yes,
thank you for this conversation for this 1 minute this day. Any other question?
I have a question to Celia. Can you explain the standard of tagging ecosystem value? Okay, thank you for the question. There are 6 parameters that can be indicated. Location is good enough for mapping tourism. There are coral cover. Its minimal coral cover is more than 15% of coral life cover. Then for water body, it is 50%, more than 50%, and for coral depth, it is 6 until 50 meters depth, and for coral life form, it is more than 7 species, and for coral and for reef fish, it is in operation, it is more than 15 species, more than 15 species, and for the current is speed current 0 until 15 centimeters per second. It is just it is.
For the online participants, maybe you have any question for the presenter.
Tanya dulu.
Yeah.
Mungkin saya bacakan.
Yeah.
Question for the first presenter. Is Udayana and endemic fish? I think it's more correct to call it native fish because Udayana also found in underwater.
Yeah. The question was
Very good.
in what Udayana is endemic. The definition is endemic in one place. What is the entry and in Indonesia? It is from the America, from Indonesia, Global, and Mango. What is the endemic fish and Mango? And the other endemic fish in the berita or global is different. Yes. What is the species name is one Nematopus. What is the potential on genetic techniques and other genetic it's different. Yes. Yes, in the history or in geography, there's example for the endemic fish in the Mango is Udayana. What the
Agus Arifin. Yang pertama.
is it clear for Miss Agus? Mr. Agus, Mr. Agus.
Agus Arifin. Ini adalah ya, oke kan.
Okay. Okay.
Oh iya.
Thank you, Mr. Yeah. Thank you, Mr. Agus. Maybe we have a question for the offline participants on the center. You have any question? No? Okay. Yes, enough. Okay. Thank you for all of the presenters and live presenters. We will continue to the online presenter, and after that we will go to after.
12.30.
Yeah. That will take
13.30, nanti masuk lagi yang lain 13.30.
yeah. For Mr. Edward Elvan Anto,
Ini tuh presensi.
Check. Is it my voice clear?
can you hear me, Mr.?
Yes.
Okay.
Is it my voice clear also?
Yes,
Okay.
you can hear me clear. Okay. Please present your presentation in 10 minutes, Mr. And then we will go to the next presenter. This time is good.
Okay, the PPT you share by your side or by my own side?
Para session itu sampai 12.30. Dan dilanjut lunch and break time dari 12.30 sampai 13.30 nanti masuk lagi para session dulu.
Sorry, Mr. Sorry.
Oh, lanjut jadi.
Yeah. Sorry, Mr. Okay, please present your presentation.
Sorry, I already share my PPT, so is by your side or by my own side? I share screen. Okay. Okay, thank you, moderator, for the kind opportunity that given to me. Hello everyone, my name is Egbert Elvan Ampo. You can call me Elephant, but not same actually. I am the one of researcher from Research Center for Oceanography, BRIN. And today I represent some of my colleagues, and I would like to deliver about topic sea bunnies as a potential marine ecotourism in Sumber Kima, Buleleng, Regency, Bali. Next. Next slide, please. I cannot be able to see my screen here. Okay, next slide, please. Next. Okay, here's the outline. Consists in introductions, research methods, results and discussion, and the last closing statement. Next. Okay, introduction. Next, please. Okay, firstly, I want to convey that one of the main backgrounds is Sustainable Development Goals by United Nations. In particularly, number 14 is life below water. So now I will present one of the most interesting underwater biotas, namely sea bunnies or nudibranch. Next slide, please. Regarding on this slide, showing nudibranch is one of the orders of the mollusk phylum that is interesting to observe because it has striking colors and varied shapes. In general, the morphology of nudibranch only consists of skin, muscles, and organs because they have shed their shells millions of years ago. Currently, there are more than 3,000 species of nudibranchs identified, both living in shallow waters, coral reefs, to dark seabeds with a depth of more than 1 kilometer, and can even be found in various types of habitats, ranging from soft mud sediment substrates to soft mud substrates and rocky hard. Next. Regarding on this slide showing about research site in Sumber Kima village, and this study aims to determine the distribution and value of the diversity, evenness, and dominant index of nudibranch, and providing an example informative infographic of sea bunnies for marine ecotourism. For the data collection on the distribution of nudibranch was carried out on the coast of Sumber Kima Village, Gerokak District, Buleleng Regency, Bali Province, in April 2021. A depth of 5 until 25 meters at 10 dive sites on Sumber Kima Bay. Next. Research methods, next. At a glance, this slide showing about the process of data collection by using self-contained underwater breathing apparatus, are so-called scuba equipment, and underwater camera, with target species of nudibranch. For species identification is done by looking at the appearance of nudibranch on the substrate from photos using an underwater camera and direct identification of the species. But if unidentified and undescribed, we further explore directly to the official website of sislakforum.net to determine the species. Next slide. This slide showing about the index value used in the process of calculating data from monitoring species of nudibranch, diversity index, evenness index, and dominant index. Results and discussion. Next, please. Next. In total, there were 50 nudibranch species that was observed in Sumber Kima from 7 genera. Philidia custulosa had the highest species count. During our monitoring, we count 8 species, while Notodoris serenae, Nembrota sp, Hypsilodoris apolegma, and Goniobranchus reticulatus were only observed once. Is uncommon species categorized. Otherwise, Philididae is a nudibranchia family that is commonly found in the Indo-Pacific region, including Sumber Kima coastal waters. Next. Here's the 15 beautiful species of nudibranch photos using an underwater camera with macro settings. Next, please. For the last result, based on Shannon Wiener's diversity index with symbol H of Sumber Kima nudibranch reveal that this community has moderate diversity and stability. This index is a widely used diversity index in which the value increases as both the richness and the eveness of the community increase. Eveness index with symbol E and Simpson's dominance index with symbol D showed that the community composition of nudibranch in Sumber Kima was relatively similar and did not display any dominance. Next. On the right side on this slide, you can see an example of infographic such as standing banner or something like that. It can be placed in local offices, inns, or hotels or resort, and other related stakeholders, such as a local government, etc. And can also be implemented into related stakeholder web links to trigger curiosity of visitors to explore directly, which is hope it can be increased the income of residents in terms of ecotourism based on that information. Next. A closing or conclusion. Okay. It is hoped that this result not only a scientific study based on the value of the biodiversity index, but can make one of the data and information on the potential of exotic underwater biota that are interesting for marine ecotourism to increase economic value in Indonesian tourist area, in particularly Sumber Kima village and its surroundings, as the one of community livelihood. Next. Voila. Finally, thank you for your kind attention. And next, please. For this opportunity, I would like to thank Institute for Marine Research and Observation under the Ministry of Marine Affairs and Fisheries for funding support, and Sumber Kima Village local government, Sumber Kima Hill Retreat, local communities, relevant stakeholders, such as Pok Maswas, Yayasan Metamorfosa, and Pok Darwis for the hospitality and very, very helpful during our survey. Thank you.
Thank you for Mr. Elvan Ampo for the presentation. We are going to the next presenter. Please, Miss Nuryani Widati.
Okay. Thank you, moderator, Ibu Made Ernawati. Can you hear my voice clearly?
Yeah.
Okay. Good afternoon, everyone. Yeah, okay. Let me start with introducing myself. My name is Nuryani Widakti. I am working for the Research Center for Oceanography, National Agency for Research and Innovation, BRIN, Indonesia. So what I'm going to share today is our work on ecological condition of the seagrass ecosystem in Lembeh Island, Bitung Regency, North Sulawesi, Indonesia. So this research was funded by the Institute for Marine Research and Observation under the Ministry of Marine Affairs and Fisheries. Okay, next slide, please. Next slide. Okay, okay. These are some points that I'm going to share here. I think next. Indonesia is part of high diversity center for seagrass species. We have about 16 species. It's 26% of total seagrass globally, and potentially one of the largest seagrass extents in the world. And this ecosystem provide various ecosystem services for human population and marine environments, like for nutrient cycling, coastal protection, food and habitat for marine biotas, maintaining water quality, sediment stabilization, and regulating and mitigating climate change. However, seagrass meadows have declined worldwide at 110 km square per year. And in Indonesia, seagrass ecosystem are threatened by various factors like coastal development, sedimentation, fisheries activities, pollution, and boating. This ecosystem have tremendous ecological services, but have the least attention from the public compared with other coastal ecosystems like mangrove and coral reefs, and are often not considered in the management plan of coastal areas. Next slide. This study was conducted in Lantai, a small island in the Gedung Regency, North Sulawesi. This island separated by Lantai Strait from the mainland of Gedung City and connects to Sulawesi and Maluku Sea. This island is close to Gedung Seaport. This is the largest and busiest port in North Sulawesi, with extensive shipping, fisheries, and industrial activities. And apart from anthropogenic stressors, this island has complete coastal ecosystems. There are coral reefs, mangrove forests, and seagrass meadows. In 2013, Lantai Strait was declared as a proposed marine protected area under the decree of the Mayor of Gedung. And the data and information regarding the status of seagrass meadows in Indonesia, including in the North Sulawesi waters, are still limited. But it was required as recommendation in following up the stipulation of the reserve decree. Okay, the next slide is this is the next slide, please. Yeah, thank you. This is the assessing the condition of seagrass ecosystem in Lantai Island. This was conducted in 2014 by our colleague Rustam et al. The study used different analytical method and only considered 3 parameters: the number of seagrass species, the number of macroalgal species, and seagrass cover. And the determination of seagrass condition is done by giving a score on the 3 parameters. And next, based on those issues, so this study aims to assess the ecological quality of seagrass ecosystem in Lantai Islands according to the 5 seagrass resilience parameters: seagrass species richness, seagrass coverage, macroalgae coverage, epiphyte coverage, and the water transparency. The next is about how we collect the data. The assessing ecological condition of seagrass ecosystem in this study is using 5 resilience that as I mentioned before. And for collecting data, we follow Seagrass Watch and CORMAP CTI guideline. And I cannot give into detail on about the guideline. And then the data were analyzed using seagrass ecosystem Seagrass Ecosystem Quality Index, or CEQI, developed by Hernawan et al. 2020. The value was classified into 5 categories. 0 is for the good condition, best condition, and 0 is for bad condition, and 1 is for the optimal condition for the resilience. Okay, next slide. Yes, next slide is about our sampling stations. We selected 8 stations for data collection. It's considering the ecological features and anthropogenic factors. 4 stations was placed in inside the Lantai Straits, facing the Bitung city. It representing high anthropogenic stress. And another 4 stations were placed outside the Lantai Strait. It's facing the Maluku Sea. Next, and the data collection was conducted in July 2019. So this slide talking about our observation recorded 8 species of seagrass, which is good enough species diversity, since 67% of seagrass species occur in Indonesia can be found in study site. So it's higher than the previous study. We recorded Thalassodendron ciliatum in Pancuran outside our line transect. And as you can see on the slide, that the location outside Lantai Strait have more diverse in seagrass species compared to the location inside Lantai Strait. And Halus acoroides and Thalassia hempechius dominant species and commonly found in all stations. According to the life history traits, these 2 species were persistent and more tolerant to disturbance. They are mixed with colonizing species that's not as good as resisting disturbance, but can recover quickly. And also mixed with opportunistic species like Samodose, Colodule, or Syringodium. And this combination of species in Lantai Island have high resilience to disturbance and adverse environmental condition. If the in contrast, if the dominant species were a colonizing species, the meadow persistence would be reduced. Okay, next slide. As indicator of environmental change and water quality, as you can see on the slide, that amplified cover a bit higher in a location inside Lantai Strait. It might be a sign that potential for water body contamination by organic and inorganic matter, mostly from land-based sources. And high atmospheric cover in the seagrass bed is harmless in clear water, but become critical in turbid waters. And the seagrass coverage was also showing the same thing in other parameters. With other parameters, it showed that the seagrass meadows in location outside Lantai Strait were denser compared to location inside the Lantai Strait. And seagrass ecosystem with dense cover and high species diversity in low turbidity areas are the prioritized zone with a high level of protection. And the next slide is describe. Next slide.
Please conclude your presentation.
I'm sorry.
We are on the slide.
Okay.
Conclude your presentation.
I can hear your voice clearly. I can continue my presentation or just
Yes. Time is up, so you can conclude your presentation.
Oh, okay. Okay, we move to the conclusion. So next one, I would like to conclude my presentation by saying that The condition of seagrass ecosystem in Lantai Island range from bad to moderate condition, and the location outside Lantai Strait has better condition than inside Lantai Strait in terms of seagrass species richness, seagrass coverage, macroalgae coverage, epiphyte coverage, and water transparency. And through this study, we suggested monitoring program to detect early changes and evaluate the trend condition. And the last one is the seagrass ecological quality index can be applied in the monitoring program since it has wider values boundaries, which is good as a precautionary approach. So I think that's all my presentation. Thank you for giving me extra time. And now I give back my words to moderator. Good afternoon and thank you, everyone.
Thank you, Ms. Nuryan. Now we are going to the next presenter. Please, Mr. Hanif Budi Prayitno.
Okay, thank you. Will you share the PPT for me or?
Yeah, we can.
Okay. Okay, thank you very much. Can I start now?
Yeah.
Okay. Okay, thank you very much. Good day, everyone. Let me introduce myself. My name is Hanif Budi Prayitno from Research Center for Oceanography, the National Research and Innovation Agency. Today, I would like to give a short presentation about site suitability of marine rensing in East Lombok, Nusa Tenggara Barat, Indonesia, based on water quality assessment. Next, please. Okay, let's move to the background of our study. So you can see the two figures in the screen. So on the left-hand side, there is Indonesian population trend, and then on the right side, there is Indonesia fish consumption trend. Indonesia fish consumption of Indonesian people is relatively low compared to other Asian countries. However, the trend is increasing. It is similar with the trend of the population growth. And in the future, it is projected that the Indonesian fish consumption will be increasing with the increasing population growth. It means Indonesia will need to increase fish production significantly in the future to meet high demand of the increasing human population. Next, please. Okay, there are several options how to increase fish production. One of them is marine rensing. Marine rensing is defined as the release of cultured juveniles into marine and estuarine environment for subsequent growth and harvest, with no intention that the released animal should contribute to the spawning biomass. Next, please. Okay, so the question is, why must marine rensing? Traditional management to increase fish production by increasing minimum size and decreasing rate to recover stock for harvest requires long period of time. On the other hand, marine rensing helps increasing seafood production while rebuilding wild fisheries rapidly through bypassing juvenile recruitment bottleneck stage. Another reason is some countries such as China, Japan, Korea, and Australia have regarded marine rensing as sustainable fishery mode, using ecosystem approach in increasing and conserving fishery resource. For instance, China earned direct economic benefits of $4.5 billion from marine rensing by 2017. Next, please. Okay, the next question is it possible for Indonesia to develop marine rensing? The answer is yes, because Indonesia is the world's largest archipelagic state where its water area is nearly 4 times larger than its land area. Next, please. And one of the prospect site is East Lombok waters in Nusa Tenggara Barat. The reason is, first, a long coastline and a number of bays in East Lombok provide proper natural condition to support mariculture. Second, seeds are available in nature. Third, national government support the establishment of East Lombok as the center for lobster mariculture. However, there are arguments against the idea of develop marine ranching in East Lombok waters. It's all related about nutrient enrichment issue. We know that nutrient is one parameter for the quality of water. And quality of water is one of the most significant abiotic factors of ecological environment to be considered in site selection. According to several studies, there report that there are seasonal fluctuation of water quality index in East Lombok water from poor to good classification. To establish marine mariculture, or especially the marine ranching, we need a stable ecological or environmental condition, because if there is a fluctuation in the environmental condition, then the cultured biota will get stressful and might not be able to adapt with the seasonal change of the environment. Okay, next please. So this is the research gap. Like I said before, that the study reported, a previous study reported that East Lombok waters, the water quality is not suitable for marine ranching because there is a nutrient enrichment issues. However, the study were conducted close to the coastline and not and net or cage mariculture. So they are not represent the whole area of the East Lombok waters. That's why our study wants to fill the gaps on the research, on the study. So our research question is Lombok water suitable for development of marine range based on nutrient level? That is the question that we would like to answer. Next, please. So this is how we do the study, how we do the experiment. So we do a bay-wide observation of macronutrients, and we did that in the second transition season in 2022, and in the West Monsoon season in 2023. The location in Ekas Bay, and then the parameters we use is DIN, dissolved inorganic nitrogen, including nitrate, nitrite, and ammonia, and then dissolved inorganic phosphate and dissolved silicate. We measure the parameters spectrophotometrically using the auto analyzer. Next, please. So this is the result. You can see on the left column, that is the result we get. And then if we compare to the previous studies, then our result is relatively lower with the other studies. That is because the other studies were conducted close to the coastline and the net cage mariculture, but our study was covering the whole area of the bay. So the result is not surprising. And then we have a wide range of the nutrient level because of the different characteristic of the area. In general, the nutrient level is still confirmed with the national standard. However, we still found the value that exceed the national standard, but we just found that only in one or two stations. And then we will look at the distribution in detail on the next slide. Okay, next. So this is the spatial distribution of DIN, dissolved inorganic nitrogen. So based on the figures, we can see that the DIN levels were higher in the West Monsoon season compared to the second transition season, and the nutrient mostly concentrated on the west part of the bay. Next, please. This is the dissolved inorganic phosphate spatial distribution, similar with the DIN. The phosphate concentration were higher in the west monsoon season compared to the second transition season. Again, the DIP were concentrated in the west part of the bay. Next, please. This is the spatial distribution for silicate, and then similar with nitrogen and phosphorus or phosphate, the DSI were higher in the west monsoon season compared to the second transition season. Again, it is more concentrated on the western part of the bay. Okay, next, please. We did a statistical analysis for the result, and for the data, and the results show that west monsoon, the nutrient level indeed higher in the west monsoon season compared to the second transition season. This high concentration or high level of nutrient in the in the west monsoon season is due to the overflowing of Awang River and Klongkong River following heavy rainfall seen from the visible coastal plumes. This presumption is confirmed from relatively lower pH and lower salinity data at the west part of the bay, which show characteristic of freshwater. Next, please. Okay, this is the pH data, lower at the west part, showing the characteristic of freshwater. Next, please. This is also the salinity, showing the freshwater characteristic on the west part. Next, please. This is the conclusion. So we got a 5 point. First, nutrient level were higher in the west monsoon season. The second, the nutrient higher nutrient in the west monsoon due to heavy rainfall resulted in excessive input of nutrient through riverine discharge. Third, in general, nutrient level in Ekas Bay are adequate and satisfy national standard. Fourth, high variability of nutrient level must be taken into account if sustainable marine range will be developed. And fifth, substantial change in environmental conditions such as nutrient over enrichment may lead to environmental issues. For instance, harmful algal blooms and coastal hypoxia. It's causing cultivated biota stressful and may not be able to survive. Thank you. Next, please. That's all. And if you have any question, I would be happy to answer. But if there is no time for the discussion, then you can send me the question through hani011@prin.co.id. Thank you very much.
Thank you, Mr. for your presentation. We're going to next presenter, Miss or Mr. Ishamil Hidayat.
Yeah, Mr. Izamil.
Oh, Mr.
Okay.
Mr. Ishamil Hidayat. Sorry.
Yeah.
We also have your video.
Yes.
You want to do presentation directly or?
Just please the video presentation.
Okay.
Good morning, everyone. Thank you for standing before today as presented at this conference. My name is Izamil Hidayat, and I'm delighted to have the opportunity to share our knowledge and research about prediction model of coral reef biota distribution in the coral triangle area of Untuk under the global climate change projection scenario. Certainly, the water of Maluku, also known as the Maluku Island or the Moluccas, are known for their incredible biodiversity and serve as the habitat for a wide variety of marine creatures. This region, located in the eastern Venezuela, has a vast expanse of ocean and is part of the coral triangle, which is considered the epicenter of marine biodiversity in the world. The coral triangle, including the waters surrounding the Maluku Island, is known for its rich coral reef, which provide a vital ecosystem for numerous marine species. The coral reef in this region support an abundance of marine life, including fish, crustacea, mollusks, and other invertebrates. However, the marine creatures in mouth waters face a numerous challenges. This including overfishing, habitat degradation, pollution, and the looming threat of the climate change. It's crucial to understand and protect this fragile ecosystem to ensure the long-term survival of these diverse marine species that call on good home. Through research, conservation effort, and sustainable practices, we can strive to preserve the natural wonders of Maluku waters and protect the myriad marine creatures that depend on this habitat for their survival. They also contribute to the conservation of the global marine biodiversity and secure the well-being of both design and the future generation. In this paper, the component of coral reef habitat projections suitability of coral as the bioindicator of coral reef, the environmental factors, and the impact of the climate change. Acropora is selected as the bioindicator of coral reef because its dominant coral species in tropical waters, such as those found in Indonesia. And the environmental factor used in developing the model include the surface temperature, salinity, current, and coastal water pollution control. And the last one is the impact of the climate change. It's about the ocean acidification will have a significant impact on the coral reef organism. Development of a habitat suitability model consists of several stages. First of all, we need data collection. All distribution data were obtained for the database. Namely, the Ocean Biodiversity Information System, OBIS, and the Global Biodiversity Information Facility of GDLN. And environmental variables were collected from by Oracle 2.2, NASA Modis Cosmi, and the MID, Global Marine Environmental Data. After that, the Maxton algorithm was used to create the habitat suitability model, and the result of our model find that projected habitat suitability map show a significant decrease in high suitability habitat area for 900 kilometers square in the current condition of the 15 to 56 per square on 2050 under forest as scenario. The ROC, or the area under curve analysis, yielded excellent result, spreading 0.9. It's indicating a valid projection model. For the testing, we feel the three variables had a significant contribution to the mode of coral habitat. And the three is temperature and the salinity. Profile exhibited the highest contribution at 7.5%, followed by salinity at 7.2%, and then temperature at 6.1%. The analysis also indicated that the seawater pH at a low contribution models suitability coral reef habitat, accounting for only 0.1%. Chlorophyll levels are associated with the nutrients contained in the water, especially phosphate level. High nutrient level indicate the presence of erosion runoff, sedimentation, domestic waste, agricultural land, and others. Therefore, chlorophyll levels are often associated with the various factors, primarily anthropogenic activities, which can reduce the quality of aquatic habitat for organisms. High chlorophyll level will increase competition between algae and zooxanthellae, thus reducing the supply for coral reef. The next factor is our temperature and salinity, variables that are correlated with the increase of carbon dioxide level in the future climate change. The increasing sea surface temperature has been detected and is correlated with the greenhouse gas level in atmosphere. The next one is to just analyze reveal that the current total of coral reef habitat area in the water of Maluku is approximately 1,654 kilometers square. Projecting this data using the maximum entropy or maxen show that under current environmental condition, based on 2020 experimental data, the habitat deemed very suitable was substantial, encompassing over half of the coral reef habitat. However, this condition is expected to decline significantly in the projected shift of environmental variable by 2050. The area classified as less suitable are between 0.25 and 0.5 will comprise half of the total habitat area, while the area classified as very suitable will account for less than 5% of its current extent. The northern side has a large area net as very suitable habitat for coral reef in the current habitat suitability map, and half of the total habitat area will be classified as less suitable, while less than 5% will classify as very suitable in the projected habitat suitability map. And also the projection map show significant decline in habitat suitability for coral reef, especially in the northern side. We need to do a policy adjustment for the coral reef sustainability, like we need to terrestrial runoff reduction, pollution monitoring, and then permanent conservation reward. And the conclusion that we can draw from this presentation, the first one is the challenge to coral ecosystem, vaccine challenge for the climate change and human activities, and the conservation of coral reef is crucial for long-term sustainability. And the second one is the significance of habitat suitability modeling. This model allows us to better understand the spatial and temporal change of coral reef ecosystem. And the last one is the importance of collaborative effort. Collective effort from the policymakers and the public are needed to maintain the sustainability of coral reef in multiple waters. I think that's all from me. Thank you very much.
Thank you, Mr. Udayana, for the presentation. Now we continue to the discussion session. If any question, please raise your hand. For online participants or listeners, maybe you have any question. Question? Maybe I think I have one question for Mr. Elvan, because maybe Sibanis is a very interesting or very beautiful sea creature. Hello, Mr. Elvan, are you there?
Yes, I'm still here.
Okay,
Thank you.
yeah. Thank you. There are specific environmental conditions for the Sibanis life. Can you hear me, Mr.?
I think it's not clear enough your your voice.
Are there a specific environmental condition for the Sibanis life?
Oh, you mean the condition of
Environmental
existing of the
condition.
Sibanis?
Yeah. Maybe in what condition it can live. We can find.
Oh yes.
Yeah.
I have seen several reference related to the existing of the Sibanis or nudibranch. The important thing is the water quality environment. So for the condition is Sibanis can be live and can be able to adapt also in the water with the such as turbidity and the salinity with the normal like a 33 per mil, something like that. But sometimes it depends also the species. Sometimes they can be able to adapt because as long as I know, in Sumber Kima Bay, they have like what we call a KJA, Keramba Jaring Apung, which is many of sedimentation processed by the what we call pakan to give the food for aquaculture, fish aquaculture. Sometimes they can be adapted because I have seen several nudibranchs can be able to live in the condition like that. So like species Goniobranchus reticulatus, they can be able to adapt also. I think for the next research can be interesting to see which species also can be adapt with the condition like that. Thank you, Moderator Erna. It's been a long time nice to see you.
Yeah. Thank you, Mr. Evan.
You're very welcome.
Yeah. So, the last session. Okay, we are going to the presentation. Okay, the honorable presenter and participant, we finally come to the end of our session. On behalf of the committee, I would like to thank all presenters for the insight and input from all participants during the session. Please give a round of applause to our thank you for the great work, and I will see you in the next event or in the next session. Okay. Om Santi 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 Om. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Fiona. Oleh para
The line provide on the
Gedung 3 sudah, Pak. Momentum atau bisa istirahat dulu, tapi 13.30 waktu Indonesia.
For the you can back to menu.
Ya, atau bisa istirahat dulu, keluar nanti masuk lagi.
Yeah.
Terima kasih.
Or you can take a rest. We will start again at
13.30 bagian dulu.
13 and 30. Bye.
Tes tes. Tes.
Recording in progress. Recording stopped.
Question and answer session. Okay, so I invite the first presenter, Kadek Aditya Premaswara.
Okay, test. Thank you, Ms. Vidyastuti, for the time and places. Can you please check the audio has not inputted yet?
Three, four, five, six,
I'm sorry, I still can't hear the audio. Can you please check the input?
Okay, Aditya, please wait a minute. We are waiting for the technician to repair the condition.
Thank you, Miss.
Okay, Aditya, can you hear the audio now?
Not yet, Miss.
Okay, how about other? Okay, so while we are waiting for the problem to be fixed, maybe we have to move to the next presenter. So, Ida Yulia Isani, are you
yes,
with me?
yes,
Okay.
I'm here.
Okay,
So
time
in
is
the,
yours.
okay, thank you very much. In this case, may I share my screen? In this case, may I share my screen? I thought to Mr. Agung, I guess, that I want to share my own screen. Is that possible? Yes. May I?
Ida, could you please wait for a minute?
Sure.
Okay.
No, I mean, like, can I? Okay, sure.
Okay, so we will. Yeah, Bu Ida. Okay, so we will show your presentation.
I'm sorry. Oh, so you will share my presentation instead of me.
Share.
Okay. So. May I start, or should wait to be on the presentation mode or something? It's still not in the presentation. Okay.
Okay, time is yours, Vida.
Okay. Okay, good afternoon, everyone. Sorry, I could not see my own presentation. Yeah. So may I? Good afternoon, everyone. First of all, let me introduce myself. My name is Ida from the Research Center for Oceanography, BRIN. Today, I would like to present the result of my research about trace metal in estuary area, titled "This Behavior of Dissolved Copper and Cobalt in Estuary, a Study from Semi and Cosby." Next, please. Next, please. Next. Trace metal in seawater play a vital role for marine microorganisms as essential micronutrients. Trace metal directly affect photosynthesis and respiration because they involve in nitrogen cycle. This is the simplified nitrogen cycles, and trace metals such as iron and copper involved in each step. Moreover, next please, trace metal like zinc, cobalt, and cadmium are required for carbon and phosphorus acquisition. Therefore, on a bigger scale, trace metal may influence the marine carbon cycle. Of those, copper and cobalt are the main focus of our today's discussion. Next, please. Next. Studies of both copper and cobalt were conducted across the globe. These maps show the occupied transect for research cruises by geotraces to study copper on left and cobalt on left. And we can see here that still lack of studies about cobalt, particularly in the Indian and Pacific Ocean. Similarly, next please. Next, please. Similarly, in estuary, distribution and behavior of copper is relatively well understood, while limited studies about the distribution and behavior of cobalt is still limited. Next, please. This study aims to determine the concentration of dissolved copper and cobalt in the estuary. And the second one, to identify the possible sources of those metals. And the last but not least one, to elucidate the main factor controlling the concentration and distribution of those metals. Next, please. The sampling conducted on board of Kakuyo Maru during early summer in Ariake Sea, Japan. Next, please. Ariake Sea is located in the Kyushu Island. Next, please. Two nexus. Please. Okay. We took seawater samples from 6 stations in Ariake Sea and river water samples from river around Ariake Sea. In addition, we also took samples from East China Sea, which you can see as the G1 and G2 stations here, and will later be defined as seawater and member. Next, please. The seawater samples were taken using acid clean ocean test equipment, while river water samples were taken using acid clean polypropylene beaker. Next, the water samples were then filtered, acidified, and stored for further analysis in laboratory. Next, the determination of copper and cobalt were conducted in a clean laboratory level 100 marine inorganic chemistry laboratory, the University of Tokyo, Japan. The concentration of copper in pre-concentrated samples were determined using HRICPMS or high resolution inductively coupled mass spectrometer, while the cathodic stripping voltammetry was used to determine the dissolved cobalt concentration in the seawater samples. Next, please. So next, move to the result and discussion. The picture on top shows the distribution of salinity in Ariake Sea, while the picture below shows the distribution of dissolved oxygen concentration. The salinity throughout the water column increased, next please, from the near shore region toward the East China Sea. And low salinity water here indicated the river water intrusion. So these are the section distribution of trace metal in Ariake Sea that tended to be higher in the low salinity water and decrease with increasing salinity, indicating that river brought these metals from the mainland into the marine environment. Next, please. To analyze the behavior of copper and cobalt in area KC, I use a simple mixing diagram of two end members, zero salinity end members, and seawater end member. The weight average values of dissolved copper and cobalt concentration were used as zero salinity end member, while metal concentration in East China Sea were used as seawater end member. The mixing line is indicated by this dashed line. If the trace metal concentration laid in the mixing line, it called as conservative behavior. On the other hand, if trace metal concentration were lower or higher than the mixing, suggested either removal or addition processes. So these are, please, next. These are the simple mixing diagram for copper and cobalt. An upward deviation was observed relative to the mixing line for copper, the figure on left, suggesting, next please, that other sources or processes probably add copper to the water column, while dissolved cobalt showed conservative behavior that suggested either its conservative behavior or supply and removal are almost equal. In the next section, I will discuss this non-conservative behavior of copper in area KC using a model developed by Boyle et al. 1977 to investigate its possible sources. Based on this mixing diagram that showed the additional supply of copper, I tried to investigate its possible sources, assuming that net flux of copper into area KC can be calculated by this equation, where R is the total river flux and C star is the actual hypothesis copper concentration in the river water if they behave conservatively. Since we showed the upward curvature in the simple mixing graph, which indicates additional input, the net flux of copper into area KC is then indicated by the sum of, next please, by the sum of flux from river water and additional input of or IE. So IE can be calculated by subtracting the river flux from the net flux of copper. The internal estimated flux is this value, and for this internal supply, I calculated several possible sources that might responsible, including sediment input, photodissolution of suspended particulate matter, groundwater discharge, and atmospheric deposition. Based on my estimation, next please, sediment input showed the highest number, and next please, it's indicating that in area KC, sediment serve as an important source of dissolved copper. Next please. It has been reported that the behavior of copper and cobalt are similar in estuary areas and indicate a similar processes govern their distribution, including their potential sources. Assuming that sediment source is also important for cobalt, I calculated the sediment flux for cobalt in a similar way how I calculated the sediment flux for copper. And for next, please. And for both metals, sediment fluxes are higher than the river fluxes. However, next please, we can see that our result shows, next please.
You have 2 minutes remain.
Okay, thank you. But we can see that they behave differently in area KC. So next please. So the different behavior indicated that different process may controlling the two metal distribution, including, please next, just show this whole slide. Okay, next, again. So we can see here that in sediment, cobalt figure below showed positive with manganese and iron, and the balance between input and removal of cobalt resulted in their apparent conservative behavior. So from this study, I can conclude, next please, that river brought both metals, next please, into the marine environments, and among those, next please, sediment is the highest supply of copper into the Ariake Sea and responsible for its non-conservative behavior, while for cobalt, the balance between, next please, next again. While for cobalt, the balance between its removal and input resulted on its apparently conservative behavior. So that's all for my presentation now. Thank you very much for your attention.
Thank you very much, Wida, for the fruitful discussion. And then we move to the first presenters. Aditya. Time is yours.
Thank you, Miss.
Assalamualaikum warahmatullahi wabarakatuh. From Jakarta, Udayana. Today, I'm going to present you our research about the combination multi-temporal representing data and learning for mathematical coverage and development. The other is Mr. Abdurrahman Shakur and Mr. Iwayan Kasawaka. We are taking from the same department of Math Science, Faculty of Marine and Fisheries, Udayana University. The first part is introduction. Our research came from the background, the benefits of mangrove ecosystem for the environment, the condition and deforestation of mangrove forest in Indonesia, and utilizing remote sensing for monitoring the extent of mangrove cover through vegetation, utilizing artificial intelligence technology, machine learning technology, and supervised learning for mapping mangrove cover and calculating its area. But then, there are few limitations from machine learning algorithms, such as the random forest models. It has a problem in relation to cloud covering factors. And then, with the advancement of machine learning models, it to build neural network, more deep learning, and then utilizing artificial intelligence technology, such as deep learning and supervised learning for long-term methods. Finally, the government must compete using multi-dimensional neural network algorithms to address verification with their own models. There is few research questions such as how does the classification result of mangrove cover from the multi-dimensional set and compare and then how does the classification report on the training result of multi-dimensional set and compared to random forest model part 3. For the time and places, we choose to test the model performance at Amra Valley and use Sentinel to take metering from April 2021 until September 2021 as the data set. This is the tools used for the research. A laptop for compute the data locally, this research data visualization and training for the labels. Python is the main language we use in this project. Google Conference Suite, the online cloud computing service from Google to run the deep learning model training. Still to take raster or imagery with 10 methods spatial resolution, which came from Copernicus and then Visual Studio Code from F94. This is the full chart of this project. We start from data collection. After that, we move into pre-processed data A, where we're going to resample the data set, subset the band. After that, we're going to move to pre-processed data B, where we're going to normalize the data with mixed scalar methods. And then we use spectral transformation for index computation, which is NDVI, NRE, and MNDVT. And then we're going to stack the raster of the data set. After that, we're going to move to create the set file label or the training area. And then we're going to convert that set file into the T files with 10 layers, which we'll explain later on. After creating the label, we're going to move into the training of the random forest model and also the multi-dimensional set. And finally, we're going to evaluate the difference between two model performance and decide which one is the best. And here's the vegetation index used in this research. The first one is NDVI, normalized difference vegetation index. We already put the formula and also the source for the index vegetation. And also we're going to use modified normalized difference water index or NDVI and also normalized difference percentage. This is an example of the training area visualization.
or the label. As we can see, we have 10 classes here. The first one is mangrove, the second one is water, and the third one is vegetation of mangrove, and many more. The author used the mangrove label only in the southwest region of the protected forest area, or Tahura, to test the model performance of the picture extraction in both model views. This is the details of our training area or labels, which tells you the total of samples we use in this project. Here is some data analysis technique we use, which call classification report. The test of accuracy, precision, recall, and one score, which came from Kohavi et al. 1998. We also will put the formula in the slides. This is other data analysis technique we use, which call conversion matrix. Conversion matrix is a matrix set table that depicts the performance of a classification model on a set of test data, where the true values are known. Here's some result and discussion of this project. The first one, the result of pre-processed data A. On the figure A, we can see one scene imagery of Sentinel-2A, while on the figure B, we can see the raster imagery after the sample into 10 meters resolution, and also have been clipped. Here's the result on how our data looks after we do pre-processed data A. As you can see, we have total number of object files. This is the example result of pre-processed data B, where we have NDVI, NDRI, and MNDVI, which will be stacked later on into our dataset. All of these three vegetation index, the range -1 to 1. The more it closes to -1, or NDVI and NDRI, it means the area has no vegetation, and the more it closes to 1, it means the area has a very dense vegetation. On MNDVI, the more it closes to -1, it shows the area has no water. The more it closes to 1, it shows the area has very rich water. This is the result of random forest model or machine learning. Please do take notes on the figure A is the classification result of the data that has been closer on the mangrove classes, while on the figure B, the data is pretty clear or without plot coverage on the mangrove classes. Through the plot shown on the figure A obtained from the first file, it is found that the random forest model's performance will be inaccurate when there is a plot cover. There is misclassification, where mangrove tends to be classified as mud, and misclassification also observed in other classes, such as cloud being classified as settlements, sand. Furthermore, based on the Python computation to calculate the area of the mangrove classes, the result of area 132.79 hectare is obtained. On the other hand, to report in the figure B, the total area of 1,033.61 hectare is obtained. Upon review, it was found that misclassification occurred, and the cloud shadows are classified as some of them being mangrove. This is what causes the obtained area measurement to be less valid. This is the result of multidimension CNN or the deep learning. The model is capable of addressing the issue of cloud cover present in the dataset used for this research. It can be observed that the details of the mangrove area, including those around the water, are well captured. Furthermore, no misclassification caused by cloud cover or cloud shadows were found. Additionally, based on the Python computation, the total area of 1,004.01 hectare was obtained. This is because the arrangement of layers in the hidden is more extensive, or in the other words, the deep neural network model has a complex structure from Mehra 2020. In contrast, the random forest model has only one layer in the hidden state, which means it has a relatively simpler structure from Kesel 2017. Additionally, deep learning algorithms handle complex tasks compared to traditional learning because they can learn multi-level representation of data input. This is achieved by multiple layers of artificial neural, where each layer represents the input data in a different way. The ability to learn multi-level representation allows deep learning models to capture complex patterns and predict the data, which can improve the model performance compared to traditional model from Video et al. 2015. This is the result of classification report, where the table A came from the random forest model. Table B is taken from multidimensional CNN. As you can see, on the random forest model, it only gained 85% accuracy and 5% of precision, 84% of recall, 84% of advanced score. The more it goes to 1 or better, the model performance is. While on the multidimensional CNN model, the total accuracy of 95% obtained 94% of precision, 96% recall, and advanced score. This result, from random model, which already described before. And also, we have figure B, which is conversion matrix from the multidimensional CNN. Well, how can we decide which one is the best? Well, we can see this graphic as a matrix. If the matrices if one is with the other numbers, set means model performance is better. As you can see here, random forest model has more classification while deciding the road classes while deciding the vegetation on mangrove. So that's why the better performance obtained by the multidimensional set and conclusion. The best classification result is achieved by the multidimensional model, where created area measurement of the mangrove classes is 1044. It is important to note that no cloud masking or image interpol techniques were applied during the data pre-processing stage. This is due to the ability of deep learning models to learn multi-level representation, enabling them to capture more complex patterns and relations. And then, in comparing the performance of evaluation models, the author utilized a model evaluation matrix, namely classification report, which consists of accuracy, precision recall, and advanced score, obtained by each model. Additionally, the author used the confusion method techniques to compare the model accuracy class labels on the test data, which accounted for 20% of the entire dataset used. Through this test, the author found that multidimensional and superior result. And that means the author expresses sincere to both parents, close family members, and to Mr. Abdurrahman Ashakur and also Mr. Iwayan Vidya Sawakara for their guidance and valuable input, enabled the author to successfully complete this research.
Okay, thank you, Dika Aditya. And then I invite the third presenter, Putu Echa Priyanka. Yes, miss.
My presentation is okay, thank you. Highest concentration in the atmosphere. Mangrove forests have the ability to absorb carbon dioxide at a rate 3 times higher than terrestrial forest and tropical rainforest. Understanding of dioxide absorption mangrove forest is in addressing and mitigating emission. One practical approach to estimate the carbon stock within mangrove forest is through the utilization of remote sensing data. Remote sensing provides valuable information to assess the forest, making it an essential tool in solving emission-related challenge. And one of the coastal areas in Indonesia that is covered by mangrove is the West Bali National Park. The West Bali National Park is nature conservation area in Indonesia. Next slide. Zone where there is a strong interaction between marine, black-water, river, and terrestrial environments, and mangrove forests are capable of absorbing approximately 63% of the total greenhouse gas emission in the atmosphere, including carbon dioxide. Next slide. This study aimed to investigate the best remote sensing index from Sentinel-2 for estimating the above ground carbon of mangrove using Sentinel-2 imagery in West Bali National Park TNBB, and the expectation of researching carbon storage are to gain a better understanding of the significant role carbon sequestration and climate change mitigation. By carbon storage in mangrove, it is hoped to provide valuable insight for conservation and management strategies, as well as contribute to global efforts to mitigate greenhouse gas emission. Additionally, the research aims to enhance our knowledge of the specific contribution of mangrove to carbon sequestration and their overall ecological significance. Next slide. And the field data collection will be conducted in West Bali National Park from October to December 2023. Data collection 2022. Sorry, and data collection was carried out on 72 research plots, and to determination of sampling points is sampling method. Diameter at breeze were taken on quadrant transect, measuring 10 meters using a soil auger. And next slide. And this is the remote sensing index data that I use. Next slide. The potential of above ground biomass is measured using the dBH diameter at risk value to obtain the above ground carbon value that in 2022 using non-destructive method, and carbon calculation using the common allometry equation and multiple regression are used to analyze the data. And this is the formula for calculating above ground biomass mangrove and carbon storage estimation. Next slide, please. And this is the wood density of mangrove, which each species has a different wood density. Next slide. And multiple regression analysis is utilized to analyze data with biomass mangrove as the dependent variable and remote sensing index as independent variable. Next. And the distribution map of carbon mangrove from West Bali National Park. Next. The total carbon in the West Bali National Park mangrove area is 465,489 ton carbon using model from multiple regression. And next slide. And the relationship between carbon storage and 15 vegetation index obtain a correlation value 0.8 and a coefficient 0.8. And the conclusion next. And conclusion this research is the total emission carbon stock of ground using Sentinel-2 multiple linear regression analyzed is 465,489 tons carbon, and the equation derived from the relationship between carbon storage and vegetation index obtain a correlation value is 0.8 and a coefficient determination is 0.6, and this indicates that the vegetation index used in relation to carbon storage in the mangrove area of West Bali National Park have significant relation in determining carbon storage estimate. So that's all my presentation, and thank you for the attention.
Okay, thank you. Thank you for the interesting topics. And next, we move to Angel Sonia.
Okay, hi. Thank you. Thank you, Miss Widya Stuti. Okay. Good afternoon, everyone. This is my great pleasure for me where we are gathered today to exchange knowledge and idea. So first of all, let me introduce myself. I'm Angel Sonia Teresia, a final year student from Udayana University, and I'm honored to address you today as I present my research with the title is Forecasting of Fishing Ground Big Eye Tuna in Southern Waters of Java, Bali using deep learning based on spatio-temporal remotely sensed data. Okay, next please. So the main idea of conducting this research is currently the uncertainty of fishing ground pose a major challenge for fishermen to increasing their catch during fishing operations. The improvement of fish catch for sustainable fishery resource management is closely related to the operational system of fishing activity, but nowadays fishermen are still generally rely on traditional fishing method and tend to use intuition and natural instinct, which consume a significant amount of time in determining fishing ground location. So the alternative approach related to predicting the distribution of big eye tuna can help to improve the efficiency of fishing operations. This aim to supporting increased fish catch productions. So the predicting fishing ground location are valuable for the effectiveness of fishing time, and the forecast of future event are used as considerations to planning, especially for fishing operations. Current research on predicting potential fishing location for big eye tuna has not yet considered the use of data time series. So this study is analyzed time series data for prediction. With the advancement in machine learning technique, algorithm, and methodology, forecasting can be applied to solve problem related to predicting phenomena or event in marine environment using oceanographic data. In this case, for estimating fishing ground can be approach based on the correlation and sustainability of oceanographic parameter with fish aggregations. The application of the LSTM model for forecasting with dataset has spent considerable time is considered more effective, thus implemented to determine the tuna fishing ground location in South Java Bali waters. Okay, next please. So the research objective and problem limitation on my research is, the first one is to determine the predictions of chlorophyll A, SST, and SSHD parameter using LSTM models. And the second one is to determine the potential fishing ground location for big eye tuna using the predicted data from LSTM model in the water of South Java Bali. And data source on oceanographic parameter that I use is 3. The first one is SST, the second one chlorophyll A, and the last one is SSHD. Through using remote sensing technique as information for predicting the fishing ground big eye tuna. And I use data monthly for predicting each parameter from 2001 until 2009, and the optimum range and HSE equation based on the result from GAM model by Setiawati et al. 2015. And next, please. This is my scope of the research that is in water South Java Bali. Next, please. So the method I use is divided into the 4 main steps. The first one is collecting data from several citra involves a temporal resolution with monthly image data and spatial resolution of 0.05 degree. And the second one is data processing include data normalization and splitting data. Then data processing include training model and the denormalization data. And the last one is model evaluation using RMS and MBA equation and HSE weighting. And next, please. So this is the simple research framework. I'm using 108-month data to input. Then the data will be divided into 2 major parts. The first one will be used for testing data in the last years as much as 25 months plus 4 months time step from 2007, and the rest is used to training and validation data. And the forecast result will be 25 months from each parameter. After that, the data will evaluate it for performance using data testing. This is for data. Okay, next slide. This is for data pre-processing is normalization equation using min-max technique and data splitting with composition data set that's shown in table. Next, please. This is a scenario training model divided into 6 scenario. Then this is the denormalization data equations to convert the normalized data back to the actual value of the previous normalized prediction during the pre-processing stage. Okay, next, please. So in the analysis, I use 2 technique for evaluation. That is RMSE, root mean square error, and MBM, and bias error, to measure the accuracy level of a model forecast and calculate overall bias. And next, please. And I use HSE equation to determine their main contributor in determining the sustainability of big eye tuna habitat. For the validation, I use conjugation table and probability of detection and false alarm ratio to validations. And next, please. Okay, this is the result. Basically, there's 3 big 3 prediction result, and the first one is learning process for the long short-term memory model was carried out 6 times based on the scenario. The selections of the main model was carried out after training data with 6 scenario and carry out for each oceanographic parameter. The model choose as the main model is based on the result of the smallest error value during the validation process. Next, please. So there will two map for prediction result of chlorophyll and actual chlorophyll value. This is the unique result based on a spatial distribution from chlorophyll A. Chlorophyll A will increase in the middle of the year and gradually decrease until the last year. Also, the cycle will be rotated in the beginning of the year. And we know that the value of the chlorophyll A will be low until the middle of the year. And the result is inverse to the SST value. Next, please. Okay, next, please. Yeah, Sam. Next, please. Next. Okay. Yes, this is prediction of SST results. Next. So this is the inverse of the chlorophyll A to the SST value, because there are many natural factors that affect the inverse value between SST and chlorophyll A. But in general, the value obtained from the prediction result of the model already described the actual value of the SST, because the pattern form tends to be relative same. And next, please.
Angel, you have 2 minutes left.
Okay. Thank you, Miss. Next, please. Okay, next, please. Also, we can see this for SSHD prediction result. The model already described the actual value from 2008 and 2009. Next, please. Next. Okay, this is so I have several map for RMS and MBA, but the time it's not. So next, please. Next, please. Next. Until the map for habitat predictions. Yes, this. Okay. Potential habitat prediction are defined based on the potential and non-potential location. Potential location are classified with HSI value 0,5, 0.5, sorry, while non-potential location have HSI value less than 0.5. The potential habitat location for big eye tuna based on the prediction using the LSTM model showed the dominant area where tuna is caught fall within HSI range out of 0.5 until 0.7. The average number of big eye tuna catch in 2008 was higher from January to May, while in 2009 there were higher from July and December. Okay, next please. So the conclusion is based on the HSI map. The reference area for big eye tuna is their waters vary depending on the mound. Next please. But the fishing location of big eye tuna appear to be constant and consistent. The in situ data indicates that the habitat of big eye tuna tends to be located towards the to the west. In the summary, the mapping of big eye tuna habitat using HSI approach provide the valuable information about potential habitat fishing location in the water South Java, Bali. This information can be used for sustainable and efficient management for fisheries resources. Okay, that's all for me. Thank you for the attentions.
Okay, thank you, Angel. The next presenter is Ida again.
Yes.
Okay, and this time
Miss Vidi.
you may share your own.
Thank you very much. Yeah, that would be great. That's so great. Thank you very much. So, may I? Can you hear my voice and can you see my presentation?
Yes, perfectly.
Okay, so let me start. Thank you. That's really nice. Okay, thank you very much. Good afternoon again, everyone. Nice to meet you again. So I would like to present my research now in the open ocean. So title Iron Biogeochemistry in the Eastern Indian Ocean. Iron is an essential micronutrient for marine phytoplankton, and it may limit their growth. Iron is a primary metal required for carbon, nitrogen, and phosphorus acquisition. Therefore, in a bigger scale, again, the presence of iron affect the marine carbon, nitrogen, and phosphorus scale. Several factors controlling the presence of iron in seawater, including its sources and sinks, such as atmospheric deposition, river input, margin, sediment, and ridges. And in addition, internal cycle of iron also control its distribution and concentration. So, Eastern Indian Ocean lies in one of the largest oceanic basin, but remains understudied, particularly for the biogeochemical cycles of metal, including iron. This area are strongly influenced by the monsoonal variation and leads to the shifting of iron limitation to nitrogen limitation depending on the season. So the purpose of this study is to reveal the iron distribution in the Eastern Indian Ocean, to understand their biogeochemical processes, and to assess the role of iron in Indian Ocean as for supporting the phytoplankton growth. So we collected samples on board of RV Hakumaru during fall intermonsoon from November to December 2018. The seawater samples obtained, then filtered, acidified, and stored for the further analysis. We use HRI CPMS to determine the dissolved iron concentration in the seawater samples. Briefly, determination of iron can be summarized to these three consecutive steps, including UV irradiation, pre-concentration, and determination. Using this method, we analyze consensus materials, and our values were comparable with the consensus values, and this indicating that this method is reliable for determining iron in seawater. Move on to the result section here. So this is the section distribution of salinity, and we capture several of oceanographic events such as jet and freshening from Indonesian true flow waters, as well as I define the principal water masses here. In addition, I also investigated the principal water masses using the TS diagram. In the deep water was occupied by Indian deep water, followed by Antarctic intermediate water and Indonesian intermediate water, sandwiched with the Indian central water and Indonesian truffle water, which occupy the thermocline. And in the surface area, we have a Bay of Bengal waters that occupy the station in the Bay of Bengal. This is the section distribution of dissolved oxygen along our transect. And one striking point here is we observe a sharp gradient of dissolved oxygen concentration in the thermocline, where ICW was the dominant water masses. In the southern station, we can see that ICW has high dissolved oxygen concentration, and the transport to the northern hemisphere accompanied with the rapid fall of oxygen concentration, and when it reached Bay of Bengal here, already in deficient condition. This oxygen deficient condition water mass then renamed NIC as NICW. So move on to the result. This is the salinity and iron distribution in the surface water. Please note the direction of north and south here. In the northernmost station, low salinity was observed, accompanied by high iron concentration, indicating that freshwater influence was most prominent in the northern Bay of Bengal. So while this is the section distribution of iron, similar to dissolved oxygen profile, the gradient of iron, we observe the gradient of iron concentration along ICW and NICW, which show higher concentration in NICW than ICW. We also observe high concentration in the near bottom water. So next we will start to elucidate its possible sources. In the water column, iron and phosphate are consumed, exported, and regenerated in association with the biogenic activity. However, external sources and scavenging of iron lead to the decoupling between iron and phosphate. Therefore, explore the relationship between iron and phosphate will give us an insight on the role of regeneration and possible iron supply from external sources. Since we found gradient of iron in the thermocline, so let's focus on ICW and ICW water mass here. And we can see that iron concentration in NICW above the trend line, which indicating that the external supply of iron into the thermocline of Bay of Bengal. Assuming that the effect of scavenging is small, so we can calculate the iron star. Iron star is a proxy to evaluate the external input of iron, and we use this iron to phosphate ratio to calculate the iron star. The result of our calculation will be in the next slide. The figure on left section is the section distribution of iron star, but the figure on right is the section distribution of iron concentration. So let's focus on this figure first. High iron indicated a high external input and vice versa. High iron was encountered in the NICW, proof that supply of iron from external sources, probably due to the high input from particulate from continental shelf. In addition, in the deep water, positive iron star were also observed, coincided with high dissolved iron concentration, indicating its external sources supply, probably from resuspension of cell sediment and the deep water movement that enrich the iron concentration here. So these are the possible sources of iron in the thermocline and the deep water. How about the iron in surface water? So these are the vertical profile of DIN, dissolved inorganic nitrogen, in the thermocline from a station that represent Bay of Bengal, Equator, and south of Equatorial region. And the gray shaded area here are the surface mixed layer. The surface mixed layer, DIN concentration consistent below the detection limit across the transect, and the detection limit is this value. Assuming that possible maximum DIN was less than this value, and phytoplankton need less than 0.006 nanomole per kilogram to iron to consume all nitrogen, while iron concentration was more than 0.006 nanomole per kilogram across our transect. This indicates that iron in surface mixed layer was depleted and sufficient to consume all DIN. Here, I try to evaluate its possible sources. First, is the river supply from Ganga Brahmaputra that will be limited only in the northernmost station, maybe station 1 and 2. And the second is the vertical flux from below the surface mixed layer. And the third one is the atmospheric deposition of iron. So on the next slide, I will focus on the iron fluxes from these two sources, vertical supply and aerosol supply. So this is the result of my estimation. The aerosol iron are higher than the vertical diffusion flux. This suggests that atmospheric deposition of iron may be responsible for the depleted iron across the Eastern Indian Ocean. Moreover, I also calculated the nitrogen flux of iron. Moreover, I also calculated the nitrogen flux from the diffusion. Yes.
2 minutes.
Okay, thank you very much. And also iron to nitrogen fluxes ratio. So the iron and nitrogen fluxes ratio are higher here. The iron nitrogen fluxes ratio here are higher than the iron to nitrogen ratio in the phytoplankton from the Eastern Indian Ocean. This indicates that iron supply is adequate to sustain the phytoplankton growth. From this work, I can conclude that across the surface mixed layer, iron concentration was depleted due to the supply from atmospheric deposition and vertical diffusion. The decoupling between iron with phosphate in the thermocline of Bay of Bengal, where iron star showed positive values, indicated supply of iron from external sources, such as release of iron from the continental shelves. And the last one, the positive iron star were also encountered at the bottom water, coincided with high iron concentration. This indicated similar external sources such as bottom sediment might supply both iron and might supply iron. That's all from me. Thank you very much for your attention.
Thank you, Bu Ida. And then we move to the last presenter, Pak Agus Arifin.
Okay. Can I present my my presentation myself?
I can see, I can hear you.
Oh,
Bisa dengar nggak? Kamu bisa dengar?
can
Oke.
you hear my voice, please? Can you hear my voice?
Oh, yes. Now I can hear you.
Okay. You can see my presentation.
Yes, Pak. Okay. Time is yours, Pak.
Okay, thank you for the opportunity. Okay. My name is Agus Hari Santosa. I read my paper with Ms. Ernik and Mr. Mining. The paper is titled Risk Assessment of Island Species in Cerata Reservoir, West Java. Okay. And the background of this research. As we know that Cerata Reservoir is a cascading reservoir in Ceratum River, which was built in 1987, which have area about 900 hectare and average depth about 34 meter, and it utilized for hydroelectric power, fisheries, and tourism. And the problem of this reservoir is carrying capacity discretion, pollution, eutrophication, and alien species invasive. The alien species in that is not native fish in the river, introduced for aquaculture, fish restocking, and habitation, and it's suspect for have a potential risk for invasiveness. The risk assessment is effort to mitigate the ecological risk of alien species, and alien species risk assessment in Cerata is still not available. So the aim of the study was to analyze of the presence of alien species in the Cerata reservoir. Okay, and the methods. This research has take a location in Cerata Reservoir, West Java, in Purwakarta, West Bandung, and Cianjur Regency. The time file survey was taken in December 2020 and to February. And the observed parameter is the ecological index, the species and the abundance, and the data analysis is fish abundance, ecological index, and the risk assessment was taken according to the guidelines for risk analysis of invasive alien species in the according to degree of the head of BKIPM in KKP. The result the and discussion this research has found the 26 species in 11 family, with the native fish only 34%, just, and the majority is the alien fishes is about 65%. Source of the fish introduction is the unintentional results from aquaculture activities, stocking for enhancement fisheries capture, and ornamental fish that are released to the reservoir. Okay, and the ecological index of fish community in Cerata, we know that the oreochromis of Nile tilapia have a high abundance in the Cerata reservoir, about 34%, and the biodiversity index and index some moderate diversity but relative high abundance of species. Index dominant is relatively stable with low dominant status, and the W index or ABC curve still has a positive value than to the miniature. Risk management. Risk management comprised to the 3 points that are risk identification, risk assessment, and risk strategy. Risk identification is a potential risk of invasive alien species based based on biological aspect. Risk assessment is the scoring of potential risk and risk status category of alien species, and the strategy is the decision-making process that can be recommended for risk control. Okay. Okay, the risk identification. According to this regulator, there are 10 criteria for potentially invasive species. There are predatory, competitor, dominant habitat, fast reproduction cycle, fast growth, adaptive, and tolerant habitat, omnivore, capable of hybridizing, disturbing fish health, and disturbing human health. That guideline is the alien fish can potentially become invasive alien species if they have at least one criteria. So this is on the table of the identification of hazard risk identification of alien species in Cirata for 17 species. Okay, dari SMS there are 5 species we have high risk. There are Amphilophus sinellus, Hemicrobus elongatus, Sibylus carpio, Ornithopus minilogicus, and Paracromis managuensis. The other species have a moderate risk. People perception toward existence of alien species in Cirata. About 60% of respondents generally understand that the term of alien and native fish. The alien is the fish from other water, and the native fish is the indigenous species in that waters. Awareness regarding of the existence of alien species, especially those are dangerous and potentially invasive, began to emerge, especially in 2030. We have the news of the issue of piranha fish. Respondents generally view the value of benefit of the present alien species in Cirata only from an economic perspective. Economically important alien fish as tilapia, carp, catfish, etc. are accepted, and the non-economic fish as Oscar, Golsom tend to be rejected. Respondent 1 export to eradicate alien fish that are considered no-sin. Okay. This is on the table. We describe the fish community dynamic in the Cirata on period 2003 until 2022. There are we can describe that the existence of alien species is menggeser, menurunkan the existence of native species. Okay. Okay, this is on the list of prohibit alien species in Cirata. There are 5 species. There are Amphilophus sinellus, Cyclosorba tricomaculatum, Hemicrobus elongatus, Mayoheras ophthalmus, and Paracromis managuensis. There are a high risk in the potency to the invasive species. Okay, as the conclusion, Cirata Reservoir identified in alien species from a total 26 species caught during the study. The tilapia had a high abundance, followed by Oscar or cichlid with 11%. The list of presence of alien species in Cirata Reservoir consists of 29.4% belonging to the high risk category and 70% moderate risk. The invasive, dangerous, and or harmful alien species that are need to be controlled are eradicated in the Cirata Reservoir. There are 5 species that are mentioned before. The potentially invasive alien species in the Cirata Reservoir need attention to control their negative impact. Okay, that is my presentation. Thank you.
Thank you, Pak Agus. Okay, so now we move to the question and answer session. So far we have 2 questions in the chat box. So Pak Yulianto asked to the presenter, but it is already answered by the presenter, and then
Miss, I'm sorry
another
to
question
interrupt you.
from Nimade Dwianita to the fourth presenter.
Hello,
Fourth
Miss.
presenter is Angel.
Miss Vidya Stuti. I haven't answered the question yet.
Bukan ke
I
ini ya,
haven't.
bukan ke Angel.
May I answer the question from Mr. Yulianto Steja?
Okay, so wait a minute, Adit, I repeat the question from Pak Yulianto. Pak Yulianto asked how the author category between the mangrove and non-mangrove ecosystem. Is there any field verification to ensure that the mangrove ecosystem is real mangrove, especially in the location that close to the land border area? Yeah, please answer.
Okay.
Aditya.
Thank you for the time before. And regarding Sir Yulianto Suteja question, first, the technique used for selecting the samples area is based on the combination of false color composite and visualization. By that, the mangrove pixel should look darker red or maroon compared to other vegetation or other trees that normally look red. And the land grass should look lighter red or more brighter. This is also to be confirmed from higher resolution satellite imagery of Google Earth Pro by ultra zooming to identify and making sure that the sample is already correct. Secondly, there are no sample of non-mangrove vegetation that is located closely to the borderland area. This is already taken carefully to reduce the chance of bias that the model will generate later on. So I just select the sample that located far from the land border area because that is too crucial. I hope my answers suit as well. Thank you very much, Sir Teja, for the question. I'm sorry if there are any errors on my words before. Thank you.
Okay, thank you, Aditya. So we move to the second question. From Nimade Dwianita to for Angel Sonia. So her question is, how do you find out the HSI value? So it can be in the range 0 to 1, according to the result of the mapping of potential big eye tuna habitat location shown earlier. Please, Angel.
Okay, thank you, Mrs. Vidya Stuti. So thank you for the questions, Mrs. Desa Soka. Based on the GAM weighting, there's a contributions value for each parameter. When the prediction results are obtained, the value will be indexed with a range of 0 to 1. According to the optimum range value for GAM research. This is a previous study. So there is 3 optimum range for each parameters actually. And after that, the HSI value will be obtained by calculating based on a mathematical equations. So there's mathematic equations, equation for each contributor parameters. Okay, that's it. Thank you.
Thank you, Angel. And then next question still from the chat box from Ibu Sekar to Pak Agus. Oke. Bu Sekar dulu. Bu Sekar ke Pak Agus. Is there any efforts, Pak Agus, from the Cirata community to eradicate the invasive fishes? For example, they kill the invasive fish when they catch. Ya, silakan
Yes.
Pak Agus.
Okay, I would to answer the question from Busakar. In Cirata, the people community of Cirata have been to do the eradicating effort to decrease the population of the alien fishes, such as the fishing fish and to utilize the fish for food and pupuk apa istilahnya. Okay, but the effort is not still not effective, but because the population of alien fishes is still abundant, so we apa namanya itu, we have the recommendation for the pemerintah to introduce the teknologi for mengurangi decrease the effect negative effect for this alien fishes. But the point is the Cirata people in Cirata community have effort to decrease the abundance of fish alien fishes.
Okay, thank you, Pak Agus. Okay, so next question is saya nggak ada questionnya. Ya. Okay, so question for dari Ilham, Prof. Ilham, for Putu Echa. Is it necessary to use 15 vegetation indices to determine the estimation of carbon stocks with vegetation indices? Okay, Echa.
Okay, thank you for the question, Mr. Ilham. Regarding use of 15 index, they are employed to stabilize a relationship between carbon stock and vegetation index. By utilize more complex index, it becomes possible to estimate carbon stock more accurately. And each of the 15 index I use in this research have specific purpose, hence their inclusion.
Okay, so thank you everyone. Thank you the presenters for the fruitful and interesting talk. So I'm afraid this is the end of our session, and okay, so actually there's still another question before I truly close this session. So question from Elvan for the 6 presenters. It is for Pak Agus. How the mitigation in terms of invasive species of fish, in particularly in your region, Pak Agus?
Okay. Okay, I want to answer the mitigation effort to protect the water from the invasive species is we have apa namanya kehati-hatian to introduce one species fish to the other to the water. So we suggest before we can introduce the it must be risk assessment before to know the risk potential for what is the that fish have a potential risk to invasive or not. So in the second, the quarantine effort in the airport, in the and etc. It must be